Yeah, hi guys. So I've been just working through building a simple UDP and TCP server in Golang and using the very basic system calls for that. And yeah, when I was building this, I got some questions in my mind, some interesting questions, and yeah, I just want to share those questions. It was a good learning experience, honestly. And yeah, I just want to share those questions and answers with you too, so that you also get some good understanding of TCP and UDP. Yeah, so these are the questions. Yeah, first of all, why do we need a syscall dot receive from in UDP, and can we actually use just syscall dot read? So, if I want to show you the code for this, you can see I've used syscall dot read here, and it is used in the TCP server, and in the UDP server we are using TCP. We are using a receive from. So, yeah, do you think syscall dot read will be useful here? If you just look at the yeah, where is it? Yeah, if we just look at the syntax, the value that it is returning, n here is the number of bytes that were read, but we don't have anything that tells us like from where the message came from, right? But in case of receive from, we actually get the socket address for yeah, the client, so that we can send some data back to it. So in case of UDP, we want to say if we want to send the data back, we have to use receive from, and a simple read will not work. But it is working in the case of TCP. So why is that? Yeah, before I go there, let me just explain. This is just quick trivia. Like syscall.read is actually just a read system call that also works on any kind of file descriptor, right? So it technically will also work on a file descriptor that is only um, yeah, that is just interacting with a local disk file as well. Okay, so yeah, why is syscall.read enough when using TCP? As we can see, that is the second question. So the answer for that is, let's take a look at the code here. Um, so here on line number 13, you can see we have created a socket, uh, and we are using that socket over here when we are accepting connections. So in TCP, as you know, we have a connection mechanism which is not there in UDP. UDP is connectionless. So when we are actually accepting a connection, we are creating a new file descriptor. Now this new file descriptor, the new socket, this is actually directly connected to the client, which is not the case for UDP. As you can see in UDP code, we are not really doing that. We are just using the initial sock FD, and for any of the clients will be talking to that. So UDP has no way to know which client from which client it got the data, but in case of TCP it does know, because the socket itself is different. If let's say uh, a different client comes in, a new file descriptor will be created here when it is accepting the connection here. And so the NFD1, NFD2, if we send data to NFD1, it will go to client 1, right? And if we send data to NFD2, it will go to the client 2. So so that's the fundamental reason of why TCP just is normal read and a normal syscall.write. As you can see, syscall.write here. A normal syscall.write on NFD works because that will send it to the client one. In case of UDP server, you can see we have a send to function. So here we are actually giving this argument here from the socket address of the client, and we want to send the data to that particular socket address. Okay, let's go to the last question. That is also quite interesting. So in the above code, if the sender sends more than 128 bytes, under what conditions do we actually lose the data? Okay, so let's try to think about this. In UDP, there is since there is no connection, the OS doesn't really provide us with a buffer to store the data. In case of TCP, actually, what happens is a small memory chunk is there on our yeah, on our machine where the data is actually, let's say there's more data coming in, let's say 500 bytes of data, then the remaining bytes will be just stored in that buffer. Over here, it will read the first 128 bytes. Where is this? Okay, here the buffer is 4,498, but yeah, if the total data is more than this, the remaining data will stay in that particular memory buffer. And as it is a loop, it will loop back and again read the next bytes until it reads all of the data. And yeah, that's why TCP is, as we know, there is no it it gives us the guarantee that there no data will be lost. But in case of UDP, we don't have that guarantee. Why is that? Why we don't have the guarantee? Because we don't have a local buffer to store the data. Any data, if it isn't read in the first pass, the remaining data is just lost. Yeah, that's just how it is. Yeah, those were the questions that I wanted to share with you. I hope you learned something.